Hello, class. You are welcome to this lesson. We are treating today present values and annuities. So, we will look at two types of annuities. We call them annuity immediate and annuity due. And then we will consider two other types of annuities, which are perpetuity and deferred annuity. Then that will bring us to the end of this topic. But in considering annuities, we'll come to understand what present values are. So we define present value as we learned in our interest theory class as the value of any payment today. All right, the value of any payment you may make over a period of time or in the future today. Now let's define what an annuity is. An annuity is a series of regular payments. So if you buy a pension fund, all right, as a worker, and then you pay regularly, monthly into that fund, that series of payments is called an annuity. Again, if you have let me use a pension fund again. If you have a pension fund and then eventually you go on retirement, okay, or your parents go on retirement, and then now they begin to receive monthly income, that income they are receiving regularly over a period of time is called an annuity. So the concept of receiving regular income, either monthly, quarterly, yearly, or by two every year, every 5 years, whatever it is, that is called an annuity. All right. So that is for your information. So let's consider the two types of annuity. We want to start with annuity immediate. So let's consider an annuity with payments of one. Let's consider we are paying just one, say one Ghana cedi. All right. We are always paying one cedi at the end of every year for some number of years, n. So we are using n years. Okay. All right. Now, this kind of payment is called an annuity immediate because payment is made at the end of the year or of the period. So let's consider this timeline where we have 0, 1, 2, 3, and then n years. Okay. This is hypothetical. We don't have a particular number of years for it. So once payment is made at the end of the year, we call it an annuity immediate. Now, the present value of such a series of payments, the present value of all this series of payments of one, that is the value of all this today at this point, is just the present value of the individual payments at time zero. The present value of one paid at one at time zero, plus present value of one paid at two at time zero. So you find the present value of each of these payments at their respective times, then you sum them together to find the present value of all of them at time zero. Okay, so let's take an example. Calculate the present value of an annuity immediate of amount 100 Ghana cedis paid annually for 5 years at the rate of interest 9%. So these are the parameters in the question. First of all, we are finding what? Present value of an annuity immediate. Take note. Of amount 100 Ghana cedis paid every year. So the amount involved is 100 cedis. The period is yearly. Okay. Paid yearly for 5 years. 5 years at the rate of 9%. Interest involved is 9%. So we've listed out all that the question is asking us to do, and we want to go ahead and then find the present value. Okay. So Um, Let me list out these things on the side here so we can use the space to find our present value. So we are finding present value is annuity immediate, amount involved 100 CDs yearly, 5 years, 9% interest rate. Okay. So we can draw a timeline. It's 5 years involved. So 0, 1, 2, 3, 4, 5. Okay. And you're paying 100 cedis at the end of the year because it's immediate. So 100, 100, 100, 100, 100 at the end of each of these 5 years. You want to find the present value of all this series of payments at time zero. Present value is always looking at the value today, and our reference point is zero. Today now is time zero, all right? Good. So what we'll do is we'll find the present value of each of these separately, then we'll sum them. So at time one, at time one, the present value of 100 to time zero is 100. You remember your discounting factor. You use v to the power 1. Okay. Now v is equal to 1 over 1 plus I. At this point, we will not be using simple interest anymore. Once we advance into annuity, our focus is going to be on compound interest. Okay. So we'll be using the compound interest accumulation factor, which is 1 plus a t equals 1 plus I to the power t. Okay. All right. So we are now going to be dividing. When we talk of discounting factor, it means that this accumulation factor takes us to the future value. But once we want to break it, we want to find present value. It means we are discounting. All right. So instead of multiplying whatever amount, say a. So if it's a, here I would have multiplied by a. Multiplying a by the accumulation factor, you would rather divide. Okay. So the present value is going to be whatever value is a divided by 1 plus I to the power t. So if you find the accumulation factor, that's the future value, you multiply by the accumulation factor. But if you are find the present value, divide by the accumulation factor. Okay. But take note that in this case, we are considering an amount of 100 cedis. So if a is going to be 100, and then v is equal to 1 over 1 plus I. So let's say v is the power t. Okay, let's put the function t because this is the case where the t there is just 1. That's how come I ignore this. This is actually 100 v to the power 1. All right. So we have this, and at time 2, bringing it times 0, we have 100 times v to the power 2. Then time 3, the present value of this 100 at time 3 is 100 times v to the power 3. The present value of 100 at time 4 is 100 times v to the power 4. And then time 5 is 100 times v to the power 5. Okay, so we can fix in the value of v. What is v? The interest rate involved is 9%. So v is going to be 100 1 over 1.09. Okay, to the power 1. And then here, which can also be written as 100 times 1.09 to the power minus 1. 1 over 1.09 is equal to, it's just represent the inverse, so it's the same, all right? So we can also write this as 100 times 1.09 to the power minus 2. Then 100 times 1.09 to the power minus 3. 1.09 to the power minus 4. 1.09 to the power minus 5. Okay. So allow me to clean this, and then let's continue. So we can find the final result, the answers. The first one is going to give us, if you check your notes, you see the 91.74. If you calculate this, you're going to get 84.17, and then all the way to the final one, you get 64.99. So what you do is to find the present value of all this series of payments at time 0. We found it. The present value of 100 at time 1 is this. Present value of 100 at time 2 is this. So to find the present value of the entire series at time zero, just add all of this to get a total of 388.97. Yes, so this is how to find the present value of a series of payments. In this case, annuity immediate. Now this is very it's quite a long process. In case you have like 20 series of payments, to go through all this will take all your time. So there is a simplified way of working out this, and we'll be looking at that shortly. All right. So if we have a series of payments where it involves n years or n periods, and you have time zero and time n, if you want to find the value of this series of payments at this time, you are finding the present value. If you're going to find the value of it at the last moment or in the future at time n, you are finding the future value. However, present value and future value can be found at any point in time on the timeline or in the entire period, in the entire period, all right? So if I can have a series of payments like this, 1, 1, 1, and I want to find the present value at time 3, it means I have to find the value of these at some days behind, okay? So present value brings you to a form of discounting. You are going backwards. So I can find the present value of these 3 at time 3. I can also find the future value of a series of payments here. If I have just these payments, I can find the future value of these values at time 4. It means I'm finding the values in the future, all right? So 1, 2, 3, I can find the future value of these 3 at time 4. So that is just for information, but generally, you'll be finding the present value at time 0 and the future value at time n. That's the last period involved. Okay. So we denote the present value of any annuity. Once again, if you have any such a series, the dot here representing that there are some number of times in between 3 and n that I have omitted. Okay. So you're paying 1 over an n year period every single year. At the end of the year, so annuity immediate, you use a symbol, the actuarial symbol A angle NI, to represent present value of an annuity immediate. Present value of annuity immediate. So we use the symbol S angle N I to represent the future value of annuity immediate. Okay. Right, so how do you find, what is the formula for the first one, the present value of an annuity immediate? So we say that the present value of the first one, if you consider this annuity, the present value of the first one, which is 1, is, so present value of this entire series, okay, this entire series is 1 is being paid at time 1, the present value is 1 times V, plus 1 times 2 is 1 times V squared. So allow me to remove the 1s, because 1 time every variable is just the same variable. So the next 1 times 3 is V to the power 3 plus all the way to V to the power n. Okay. So this is a summation of a geometric series, which is equal to A 1 minus r to the power n all over 1 minus r, where A is your first term, n is a number of series, and then r is the common ratio. Okay, common ratio. So in this case, our okay, so A is equal to V, and then common ratio is equal to V. So our present value then is equal to A, which is V, times 1 minus the common ratio R is referring to this sum of geometric series formula. Okay, this is a sum of geometric series. 1 minus V to the power n all over 1 minus V. But from our interest theory class, we realized that, or we noticed that 1 minus V is also equal to I times V. Okay, so this is equal to V times 1 minus V to the power n all over I times V. The V's will cancel out, and eventually we have 1 minus V to the power n all over I. Okay, so in simple forms, the present value of an annuity-immediate is equal to 1 minus V to the power n all over I. Okay, so this is it. All right, so let's take a question and attempt to solve it. So we will take the question we solved early on, where we had a series of 5 payments of 100 cedis each at the end of the year. We solved it early on. We want to now use the formula, this formula, to solve it, instead of doing it step by step like we did. Great. So to find the present value of this series, n is what? N is 5. Interest involved was 9%. Okay. I equals 0.09. Good. So 1 minus what? V. V is 1.09 minus 1. And the n involved is 5. So we'll multiply the 1 here by 5. Okay. Sorry. Minus 1 times 5. All divided by I is 0.09. So if you put this in your calculator, you can simplify this to get 1 minus 1.09 to the power minus 5 all over 0.09. And if you fix this in your calculator, you should get the same answer as we got before, 388.97. This is quite a faster way to do it, especially when your n is quite huge. N maybe 50 years or a 50 period we are considering. Okay, so we are done with the example. Okay. So you can also find the future value of an annuity-immediate. I usually use S to represent S angle N, I, to represent the future value of an annuity-immediate. Future value of, we are looking at annuity-immediate, so let's just end the future value, okay, of annuity-immediate. Okay. So to find the future value of annuity-immediate, you can use the annuity, the present value, to find the future value. All right. So once you have a series of payments of this sort, up to n, and then you've done your calculations and you found the present value at this point, you want to find the future value. This one is going to be a value. When we did the example we did, we had 388.17. So this is a value. Okay, so it's a certain number you will get, it's a certain amount you will get. If you want to find this amount in n years' time, from interest theory, what do? You multiply this amount by the accumulation factor. So to find the future value, S angle N, that's the value of this here, S angle N, I, we will take this amount, A angle N, I, then we multiply it by the accumulation factor, which is 1 plus I to the power n. Okay, 1 plus I to the power n, because n period, we want to find the value of this at time n. So we simply multiply by the accumulation factor. So how do we further simplify this to get a formula for the S angle NI? So S angle NI is equal to A angle NI was given away, so we got 1 minus V to the power n over I. Okay, multiply by 1 plus I to the power n. We can further open this up to get 1 minus, this is 1 plus I to the power minus n, because V is 1 plus I to the power minus 1. Okay, all over I, multiplying everything by 1 plus I to the power n. So the 1 plus I to the power n is coming into the bracket to multiply everything in the numerator. So 1 plus I to the power n will multiply 1 to get 1 plus I to the power n minus 1 plus I to the power minus n times 1 plus I to the power n. The minus n and n's add to cancel out. So eventually minus n plus n is 0. N minus n is 0. So any number to the power 0 gives you 1. So this is going to be 1 plus I to the power n minus 1 all over I. So this is the formula for future value of an annuity immediate. Okay, the future value of an annuity immediate. What I was talking about these two is that if you consider 1 plus I to the power minus n multiplying 1 plus I to the power n, we are multiplying some powers of exponents. Okay, so this is 1 plus I to the power minus n plus n. N minus n is 0. You have 1 plus I to the power 0, which is equal to 1. That's how come we have 1 over here. Great, okay. So there's one more, there are many examples in our notes. There are many examples in the notes you can make time to work on and try your hands on. Let's solve one more example before we move to the second type of annuity, which is annuity due. Okay, so the example says, find the present value of an annuity immediate of amount 100 cedis paid quarterly for 10 years at an annual rate of interest 8% convertible quarterly. Also calculate its future value at the end of 10 years. So what we are doing here is that, if you remember from interest theory class, we dealt with convertible quarterly, the case of nominal rates of interest. Okay, so it's coming in here in this example. Let's attempt to solve it. This will be our final example for annuity immediate. So that we want to find, first of all, we want to find what? Present value. Okay. And then it's of what? Annuity immediate. Amount involved is 100 Ghana cedis. It's paid every quarter in the year, which means it's paid 4 times in a year. Time involved is 10 years. Okay, 10 years. And interest rate involved is 8% convertible quarterly. So 8% convertible quarterly. Okay. So the payment is made every quarter, interest is converted every quarter. Great. So how do we solve this? Okay. First of all, we know the present value of an annuity immediate is 1 minus so 1 minus v to the power n all over I. If you have an amount involved, let's say A, They're paying A periodically. Then you multiply the whole everything here by A. Okay, great. So in this case, the amount being paid is immediate. So at the end of every quarter is 100. The years involved is 10. I would want to draw my timeline. It makes things easy for me. So 0, 1, 2, 3, all the way to 40. Why 40? I'm using a quarterly period. I'm not using the years. So if there are 10 years and in every year you pay 4 times, you end up making 40 payments. 40 payments of 100 cedis each. Okay. All right. So coming back to the case of nominal rate of interest, we are dealing with quarterly payments and we are going to be converting the interest every quarter. But this is 8% convertible quarterly. So then the effective interest rate to be paid actually every quarter is 8% divided by 4, which is 2%. So 2% is the actual interest rate we'll be using for every quarter. Okay, so the 8% here is this a nominal interest rate for the year, but it's convertible quarterly, so you must divide it by the number of quarters within the year. All right, so we have our interest rate, which we will be using in this quarter, which is 2%. And then we have the number of periods. Number of periods involved N is 40. There are 40 quarters. We are not working in respect of 4 quarters. So there are 40 quarters involved here. So to find the present value, you use a formula which is 1 minus v to the power n all over I times your amount involved. So 100 being paid, 1 minus v is 1.02 times to the power 1.02 to the power minus 1 times n involved is 40 all over I is 0.02. Okay, so this is it. And once you do this, you just put all of this in your calculator. You can do step by step. Do the numerator first and then come and divide it by this, multiply by 100, and you write down your final answer. Okay, all right, so this is how you find. It's the same using present value formula in this case, but it's just that we consider a case where the interest rate involved is nominal and it's being converted over some periods in the year, and the amount being paid is also being paid over a number of times in the year. Okay, so this is the nature of questions you should be practicing and be expecting for your assessments, including your examinations. So there are example 4 and example 5 are available in your notes. You should make time and then give them a try to ground your understanding. See you in the next session where we'll be treating annuity due.